So hello and very good morning dear students. I hope you all are ready for mathematics classes. So talking on the topic which is going on in the class, that is inverse trigonometric functions, we are about to end the exercise, that is the last exercise we are on, and we need to understand some more questions as in the previous 3 videos which I have shoot for you, that is the basic properties, important formulas, important results, the basic things of the chapter, and some questions related to the first exercise. I heard many of you are not getting the questions from the second exercise, so I'm going to take some questions from it. So let's see the questions now. Okay, now let's come to the question which I have written here, that is tan inverse 1 upon root 3 tan x upon 2 equal to half cos inverse 1 plus 2 cos x upon 2 plus cos x. This is the question with us. This is, I think, third question of your exercise, third one. How to start this question? Because on seeing this, it is very much complex to understand what to do, how to start. Okay, so just see how I have done. First of all, I have manipulated the proof as I've taken this to this side, so it will be 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. I hope up to here you can understand that. No, sorry, this is the identity actually. I've taken this 2 here and I'm manipulating the proof as now I need to prove 2 tan inverse 1 upon root 3 tan x upon 2 equal to cos inverse this whole. Okay, now from here how I have started, that we know 2 tan inverse x identity, that is cos inverse 1 minus x square upon 1 plus x square. So using this identity here, in place of x you have this whole quantity, so using cos inverse 1 minus, in place of x we have this, so 1 upon under root 3 tan x upon 2 the whole square upon 1 plus this the whole square. Now it will be tan square x upon 2 whole by 3, and it will also be tan square x upon 2 by 3. Taking LCM, 3 will be multiplied here also 3 to 3 cancel in the denominator, and we'll get this as the answer. Now keep it as it is, come to the RHS part, because LHS we got up to here. Okay, so keep it now, come to the RHS. So cos inverse this, so taking the RHS here, okay, and here I have taken the LHS. So RHS is this one. But before that, let's see what are the formulas we have. We have one formula, that is cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. If I ask you that do the half of this angle, so it will be cos theta equal to 1 minus tan square theta by 2 upon 1 plus tan square theta by 2. So putting all the values, that means in place of cos x we can put this whole, and in place of this cos x also we can put this whole quantity. And if you can take the LCM of this, so it will be 1 plus tan square theta by 2 plus multiply this 2 inside, so 2 minus 2 tan square theta by 2. Here also multiply this quantity here, so it will be 2 plus 2 tan square theta by 2 plus this. Now can you see that this cos inverse here, 1 plus 2 is what, 3, and tan square theta minus 2 times of tan square theta will give you tan square. Okay, sorry, see here x will come, so correct it. Okay, because we are dealing in x, so that is why x will come. Okay, so yeah, so tan square x by 2 minus 2 times of tan square x by 2 will give you minus of tan square x by 2. 2 plus 1 3, and 2 tan square x by 2 minus tan square x by 2, you will get this. So finally, as the LHS result is equal to the RHS result, they both are same, so hence it is proved. Like this you have to prove. Okay, see, one thing I just want to let you know, that whatever question we are doing in the second exercise, you have to keep in mind what are the logics or what are the algorithms which we have used here in the solution. The reason being, in the differentiation chapter as well as in the integration, not much in the integration, But talking about the differentiation chapter which we are going to study, in that chapter this has a separate exercise, and believe me, on we don't have to that means on differentiating we won't face the problem, but on simplifying the inverse trigonometric function we'll face the problem. So that is what I'm saying, that while we are doing these questions, please do them very thoroughly, okay, and understand that how to do this type of questions, because in differentiation first you need to simplify, then only you can differentiate. Okay, so please focus on this question and this chapter very nicely. You know, relation functions, inverse trigonometry, these two chapters are somewhat very important for the calculus. Okay, so you have to keep in mind this thing. All right, coming to this question, we have tan inverse root of 1 minus x over 1 plus x. How to solve this question? No one can like figure it out that how we can do, but here in this we have to use some of the other logic just to make it very easy. Okay, because the question is write the following function in the simplest form. That means we need to write this in the simplest form, that how much simplest you can write. So what to do here? We will use substitution method, that is we need to substitute x. Now if I ask you that what are the possible what are the possible things which you can place here in place of x so as to remove this root. So if I put x as sine, cos, tan, I won't get anything, right? Because 1 minus sine is nothing, 1 minus cos is also nothing, 1 minus tan also, it won't give us the answer. But if I put x is equal to cos 2 theta, okay, now why I am putting cos 2 theta? Actually you can put cos theta also, that will also give you the correct answer. Now why I am putting cos 2 theta? This will give me a more like simplest result. I'll tell you how. But before that, as we are considering x is equal to cos 2 theta, so here take this cos here, so it will be cos inverse x is equal to 2 theta, or the value of theta will be, if you take this 2 here, so half times of cos inverse x. Just keep it aside. Now why I have let this as cos 2 theta? Because on putting here, just put the value, it will be tan inverse under root of 1 minus cos 2 theta upon 1 plus cos 2 theta. Because 1 minus cos 2 theta will give you 2 sine square theta. So see what I am saying, this is by the identity I can mention it as 2 sine square theta, and this will give you 2 cos square theta, 2 to 2 cancel, sine square theta upon cos square theta, or it will be a tan square theta, and when it will come out it will give you tan theta. And by the self-adjusting property, tan inverse will self-adjust with this tan to give answer theta. Now in place of theta we already found x theta is equal to half times of cos inverse x. So that is how tan inverse, this can be written as half times of cos inverse x. This is the reason why we have considered cos 2 theta. Also you can consider cos theta also. The only difference is here it will be cos theta, here it will be cos theta. Now the formula of so what will be theta from here? Cos inverse x. Now what happens? It will give you 1 minus cos theta will give you 2 sine square theta by 2, and 1 plus cos theta will give you 2 cos square theta by 2, and it will be tan inverse tan theta by 2, so theta by 2. So as on putting the value of theta as cos inverse x, so half times of cos inverse x, hence proved. So like this you have to do. I hope you have understood this method. Okay, now let's see this question. It says tan inverse 1 upon 7 plus tan inverse 1 upon 13 is equal to tan inverse 2 upon 9. We need to prove that the sum of these two gives this one. Okay, so let's start taking LHS. The LHS we have is tan inverse 1 upon 7 plus tan inverse 1 upon 13. We know by the identity that tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Okay. So using the identity here, we can say tan inverse 1 upon 7 plus 1 upon 13 upon 1 minus 7 upon 1 minus 1 by 7 into 1 by 13. Now take the LCM here. So it will be 13 plus 7. So it will be 20 upon 13 into 7 is what? 91. Here also 1 by 7 into 1 by 13 will give you 1 upon 91, which is 1 minus 1 upon 91. I hope you have understood. 20 upon 91, take the LCM. So 90 upon 91, 91 to 91 cancel, 0 to 0 cancel. You got tan inverse 2 upon 9. So such type, see, for doing this type of questions, you must be well versed with the identities and formulas which we have seen earlier in the videos. Okay. So just you have to keep in mind those identities and formula and you can easily do it. Okay. So, okay, let's do some more questions. Okay, now let's see some different type of the inverse trigonometric functions if we are given with. So, see, here we have to prove that sine inverse 4 upon 5 plus cos inverse 5 upon root 5 is equal to cot inverse 2 upon 11. This we have to prove. So how can we prove this? The very first thing is you have to convert either this sine inverse in terms of cos inverse or this cos inverse in terms of sine inverse, because we have the identity of sine inverse x plus sine inverse y plus minus, and for cos also we have cos inverse x plus minus cos inverse y. We don't have a such kind of identity where sine inverse x plus cos inverse y. Okay, so that is why we need to convert either this one or this one, and final answer will get in sine inverse. Then we will convert that sine inverse or cos inverse in terms of cot inverse and we'll get the answer. Okay, so let's see how we have to do. I'm changing this cos inverse in terms of sine, so I'll consider that let cos inverse 2 upon root 5 is equal to theta. So I'll get cos theta equal to 2 upon root 5, isn't it? Okay, we know cos theta is what? Base upon hypotenuse. So what will happen with the help of this information, we can easily make a right angle triangle having the base 2 and hypotenuse 5 root 5. So can we find perpendicular? Hypotenuse square minus base square, 5 minus 4 1, so the perpendicular will be 1. With this triangle we can easily make out sine theta, which is what? Perpendicular upon hypotenuse, okay, which is 1 upon root 5. Okay, the sine can be taken that side, so theta equal to sine inverse 1 upon root 5. If our theta is cos inverse this and our theta is sine inverse 1 upon root 5, that means they both can be equalized. So in place of cos inverse 2 upon root 5, we can easily put sine inverse 1 upon root 5. So on placing it, it will be like this: sine inverse 4 upon 5 plus sine inverse 1 upon root 5. Now can we use the identity sine inverse x plus sine inverse y? What is the identity? If you are remembering, sine inverse x plus sine inverse y is equal to sine inverse x root 1 minus y square plus y root 1 minus x square. I hope you remember it. On using, we'll get sine inverse bracket x, our x is 4 upon 5 into under root of 1 minus y square, 1 upon under root 5 the whole square, plus y, 1 upon under root 5 bracket under root 1 minus x square, in place of x square 4 by 5 the whole square. Okay, yeah. Now can we we can calculate here only. Root 5 square will be 5, so 5 minus 1 4, 4 upon 5, on taking it out will get 2 by root 5. Okay, and this 1 upon root 5 will remain as it is. So here it will be what? 25. So 25 minus 16 will give you 9, which is root, that is on taking out from the root it will get 3 upon 5. Okay, So sine inverse, this is 8 upon 5 root 5. See, this is 5 root 5, 5 root 5. So commonly we can say 5 root 5, 8 plus 3, 11. Okay, so sine inverse 11 upon 5 root 5. We got this as the result. Now with this result, again what we have to do, we have to consider this is equal to, you can consider after this, because we need our answer in cot inverse, our answer came in sine inverse. So again what we will do, see, after this, consider, again you have to consider sine inverse 11 upon 5 root 5. Now you consider phi, because we cannot consider theta, because in the same solution two different thetas cannot be taken. Okay, so equal to theta, take sine that side, so it will become sine phi equal to 11 upon 5 root 5. Again making a right angled triangle, sine theta is perpendicular upon hypotenuse, so perpendicular is 11, hypotenuse is what, 5 root 5. Okay, so after that, what is the that is hypotenuse square, what will be the hypotenuse square, 25 into 5, so it will be 125. Okay, 125 minus 121, it will give you 4, which is the root of 2. Okay, taking root, that is 2. By PGT you can find all this. Okay, we need cot, so what will be cot phi from here, base upon perpendicular, base is what, 2, perpendicular is 11. Okay, take cot that side, so phi is equal to cot inverse 2 upon 11. Phi was sine inverse 11 upon 5 root 5. Phi came cot inverse 2 upon 11. They both can be equalized. So after this, what? After all this solution, we can say this can be written as cot inverse 2 upon 11. Hence proved. I hope you understood this. Okay. Okay, so dear students, that's it for this lecture. I hope you have understood all the questions. We'll take some more questions in the coming video. So till that, how much we have done, do the practice of this and see the examples also. You know, there are, if I open the book, so there are around 54 examples in your book, and in which the subparts are also there. So around 100, more than 100 maybe the examples, and in the exercise there are just 19 questions and subparts are also there. But you see the importance of examples, as they have given so much of examples rather than giving them in the exercise. So what they are trying to what they are trying to just say that the examples are a bit important, because from the examples you can see many questions were selected for the board examinations. Okay, so try to focus on them. Okay, in the next video we'll come up with more questions. Okay, do the practice. Thank you so much. Have a nice day. Bye bye.